Finding the sum of a geometric series. You're basically finding the sum of a value of a series. So you're adding together a sequence of numbers, and a series also tells you that it's going to be continuous. Okay, so it's not the first 10 terms, there are 20 terms. It's like all of the terms. So for a series of numbers that you're adding together, so a sequence of numbers that you're adding together, that goes on forever, basically. Okay? So there is going to be a sum if the R value, if the absolute value of the R value is less than 1. So that basically means the R is less than 1 or greater than a negative 1. So any of those fractional values, positive or negative, that are less than 1 or greater than a negative 1, then you use this formula. The sum is equal to the first term, so in this case that'd be a negative 81, over 1 minus R. Okay, and so remember, you can figure out what R is by taking a value and dividing it by the one preceding it. So 3 over a negative 9 in this case gives me a negative 1/3. And you'll find that that'll happen for any of the two corresponding values that you use here. Okay, as long as they're consecutive. Okay, so this one's going to have a sum. But if I had a value where my R value, the absolute value of R is greater than or equal to 1, so basically it's greater than or equal to 1 or less than or equal to a negative 1. So 4, negative 4, those would all have no sums if your R value is a number like that. Okay, so let's look at a couple of examples really quickly. Okay, so here you have this formula where you're adding up these values, and in this case, the way this is presented, you can see that your first term is 1/3. Okay, so let's look for A. Let's go ahead and change that color so you can see what I'm doing here. So A sub 1 is going to be 1/3. And your R value, so you could take this second term and divide it by the first term if you wanted to find R. But you can see that what you're doing each time is multiplying each value by 1/3. So R is going to be 1/3. So we need to plug this into the formula. S equals A sub 1, so that was 1/3, over 1 minus R. So 1 minus R is 1/3. Okay, and so now you just need to simplify this. So remember that we can write this 3 here, this 1 here, as 3 over 3, so that we have a common denominator, and 3/3 minus 1/3 is 2/3. So we have this complex fraction, but remember this is the same thing as 1/3 divided by 2/3. Whether we write it either way, it means the same thing. And so remember, when you have something like this, you're simply going to take 1/3, multiply it by the reciprocal of this number here. So this is going to be 1/3 times 3/2. And you can see here that you can simplify the 3's, and this is going to leave you with 1/2. So the sum for this first example is 1/2. If you add all of the numbers up together, it will get closer and closer and closer and closer, essentially reaching 1/2. Okay, think about that. And actually kind of check it out if you'd like to. You can kind of see what's happening there. Okay, so for part B, remember that this means to find, it's asking for the sum of the first term through the infinite term. So the sum of all of these items. Now, one of the things you can do is go ahead and kind of calculate this out. So replace 1 here, you're going to get a negative 2/3 if you replace I with 1. That's your first term. Plus, now replace I with 2. And so that's going to give you a negative 2/3 to the second power. Plus, if you keep going, you're going to get negative 2/3 to the third, and you can see the pattern here. So you can see here that your first term, A sub 1, and I should have put a 1 there, is equal to a negative 2/3, and R is equal to, and in this case too, you can see what R is because you're multiplying each side by a negative 2/3. A sub 1 and R are not always going to be the same, they just happen to be in both of these examples. Okay, so if that's the case, then the sum is, remember the formula we're using is 1 over a sub 1 over 1 minus r. So we're going to plug this in. So a sub 1 is a negative 2/3 over 1 minus a negative 2/3. Okay, so we can see from this that I can change this minus a negative to plus a positive. So I'm going to be adding 2/3 to 1, so I can think of 1 as 3/3. And so 3/3 plus 2/3 is 5/3. So I've got a negative 2/3 divided by 5/3. Okay, so essentially what we've got here is a negative 2/3. If we're going to divide it by 5/3, it's the same as multiplying it by the reciprocal 3/5. And we can see that these 3's will cancel out and or simplify, and leaves you with a negative 2/5. And that is going to be the sum. And remember, we could find the sum of both of these because the r values were between -1 and a +1. Okay, let's look at another example. Okay, so in this case you can see that the r value is going to be not the same as the a sub 1 value. Okay, so the first example, a sub 1 is going to be 3 times a negative 4/5. So I'm going to think of this as 3 over 1. So it's going to give me a negative 12/5. I'm just going to leave it in that form. And then the r value, you can see that the r value, I'm multiplying each term by an extra negative 4/5. Negative 4/5 is in between -1 and +1. So this one's going to have a sum. So again, you're just going to plug it in. Remember the formula? S equals a sub 1 over 1 minus r. So we're plugging that in. So a negative 12/5 over 1 minus a negative 4/5. Okay, so we're going to change this to plus a positive. We're going to think of this 1 as 5 over 5 so that we can add those together. Get a negative 12/5. And that's going to be divided by 9/5. And we're going to change that to negative 12/5 times 5 over 9. Remember, because we're take the reciprocal of this value. And we're going to negative 12 over 9, and that's going to simplify. We can divide both of those by a 3. And so it's going to give me a negative 4 here. So a negative 4/3. And that is your sum for that geometric series for the first example A. Okay, so let's look at B real quick. Okay, so it's the sum of the first through the infinite number of terms right here. So let's plug in k for 1. So we get 3 times 4 to the first power. That's our first term. And then our next value, our next term value would be 3 times 4 squared. And put the 4 in parentheses so it kind of follows that pattern if you want. And that is not, I'll just do that so you don't think it's a negative. Plus 3 times, we replace the k with a 3, we get 4 to the third, and you get kind of the idea of what's going on here. And you can also see, you can see that a sub 1 is going to be 3 times 4 is 12. And then we see that r is going to be, you're multiplying each term by a 4, so r is 4. So remember what happens if r is 4, this is greater than or equal to 1, so this is no sum. And that's what you put for your answer.